So this is just a little bit of practice for writing each equation into the exponential form. You can get through these pretty quickly, right? So log base 5 of 25 equals 2 can translate into the exponential form as 5 raised to the second power equals 25. You're just working with the properties of the logarithm. Log base 4 of 64 equals 3. Again, 4 to the third power is equal to 64. And you should remember this from the Algebra 2 curriculum. Now, here we have log of 100 equals 2. So this is the common log. It's log base 10. If you need to write a 10 here, that's fine. But what you don't want to do is leave an answer that's a common log. And you don't want to write that base 10 in there. You just want to write 10. You just want to write log of whatever the argument is. So in this case, it's 10 to the second is 100. And then number 4, log base 4 of 1/16 equals -2. So in this case, 4 to the -2 is 1/16. Right? And all of these are true statements right now. We started with the warm-up that was not the same as this, but in a similar presentation as the exponential form. We're just now taking it from the logarithmic form and moving it into the exponential form. All right, so what we're going to do now is we're going to take a logarithmic expression. I'm calling this an expression because there's no equal sign anywhere. And we're going to evaluate it, which means tell me what the value of this logarithmic expression is equivalent to, okay? Personally, I think the best way to do it is to introduce an equal sign to help you make sense of the logarithm first, and then eventually some students kind of move away from using an equal sign, and then they can just evaluate it, right? So here's the idea. We don't want to use a calculator on this problem right now. We want to show all the analytical steps and the mathematics behind it. So if you're dealing with an expression, you can create, an equation to help you make sense of it, but just remember, you're not solving an equation right now. You're only evaluating this logarithmic expression. So your answer should be a numerical value. It should not be a equals. And we're going to start first by just converting it to exponential. So this means 3 to some unknown exponent is equal to 27, right? So 3 to some unknown exponent is equal to 27 here. And then this is more related to the warm-up, right? Can I rewrite these in the same base? I can. 27 can be expressed as 3 cubed, right? So on the left side, I still have 3 to the a. On the right side, I have 3 cubed now. And now I know that my exponents are equivalent because the bases are the same. So a must equal 3. That's a true statement, but the answer is not a equals 3. It's just a, okay? It's just 3, right? So the answer here is 3 only, not a equals 3, just 3. Okay? That's number 1. Number 2 is down below. Oh, run out of space here. Okay, so number 2, same idea. If you need to create an equation, go for it. You can write an A here. Some people use a question mark, but again, it's log base 2 of 16 can be converted into an exponential format as 2 raised to some exponent is equal to 16, right? So 2 raised, some people will use a question mark. I think it's best in some cases just to use a variable. So 2 to the a is equal to 16. I know I can rewrite 16 in base 2, right? 2 to the 4th is equal to 16. So this is 2 to the a equals 16. Therefore, my exponents must be equal. So a must equal 4. So the answer to this question is just 4. It's not a equals 4. Number 3 can cause a little trouble for some of us. Log base 5 of 1 equals 0. Log base 5 of 1 equals, right? So I'm going to just say a right now. Again, convert it to exponential. 5 to the exponent of a is equal to 1. Now here we can't rewrite them in the same base, but you have to understand that 0 exponent property, right? Any number other than 0 raised to the 0 exponent is always equal to 1. So then in this case, a must be equal to 0 or just 0 as our answer. Back up to the top. So log of 1/1000, right? This is a natural, excuse me, this is a common log. There's usually, base 10 is right there. We just don't write it when we're using the common log. But again, you have to create an equation, go for it. So this is saying 10 to the a equals 1/1000. 10 to the a equals 1/1000. I can rewrite these in the same base. 1,000 is really 10 cubed. So it's really 1/10 cubed at the moment. And then I don't want 10 cubed in my denominator. I want it in the numerator. So it's going to be 10 to the -3 is equal to 10 to the a. Therefore, a must be -3. Answer to this is -3, not a equals -3. Now it's going to get slightly more complicated. So log base 8 of 2 equals some unknown value. Convert it to exponential. So 8 raised to the exponent of a equals 2. Right? Yeah. So then 8 can be expressed as 2 cubed to the a equals 2. I'm going to write a 1 here because it's a little bit easier to make sense of. I can use my power property here. When I'm raising an exponent to an exponent, I'm going to multiply these exponents together, right? So that's going to be 2 to the 3a is equal to 2 to the first. Therefore, my exponents are equal, which means a must be equivalent to 1/3. So the answer to this question is just 1/3. And lastly, number 6, log base 27 of 3 equals some exponent we don't know yet. Again, convert 27 to the a, exponent equals 3. I want to rewrite in the same base. Be careful with these. Just our mental math can trick us and we can kind of leave the wrong answer because we're not really focused. 27 can be expressed in base 3. So 27 is really 3 cubed to the a is equal to 3. I'm going to write a 1 here. And then we keep going, right? So use that property, power property here. So that's going to be 3 to the 3a is equal to 3 to the first. Therefore, I know my exponents are equal. 3a must equal 1. Therefore, a must be 1/3. Or just evaluating that logarithm gives you 1/3. Here for you to practice on your own real quick, and I'll show you the answers in a second. So here's the work. For each one, I created an equation to help evaluate the logarithm. But remember, we're not solving an equation. Our answer must just be a numerical value, not a equals. So 36, log base 36 of 6. I converted it to exponential. I rewrote 36 in base 6, so that's 6 squared to the a. Use that exponent property, so 2a equals 1. And then a is 1/2. And that should make sense if you think about what we said the meaning of a logarithm is, right? So the logarithm here, log base 36 of 6 is saying 36 raised to what exponent is 6? And we got an answer of 1/2. Remember, an exponent of 1/2 is the same as the square root, right? So that's saying 36 to the 1/2, or the square root of 36, is equal to 6 itself. Log base 1/5 of 125. Again, I created the equation. I converted it to exponential. 1/5 to the a equals 125. This is a scenario where I have to work on both sides to rewrite in the same base. I don't want to work in a base of 1/5. I want to work in a base of an integer as opposed to a fraction there. So 1/5 can be expressed as 5 to the -1st, right? If you think about this as being 5 to the first in the denominator there, then I can rewrite it in the numerator as 5 to the -1st. Use that exponent property, 5 to the -1st to the a gives me 5 to the -a, which is equal to 5 cubed. Remember, 5 cubed is the same as 125. And then my exponents must be equal, therefore A must be -3. So when I evaluate the expression, the answer is -3. And then lastly here, log base 3 of 1/81st. It's going to translate into the exponential format as 3 to some unknown exponent equals 1/81. So on the right-hand side, I have to take this 81 and write it in base 3, which is 3 to the 4th. But I don't want to use a fraction, so I'm going to rewrite it with a negative exponent here. And then my exponents must be equivalent to each other now that the bases are the same. Therefore, the exponent must be -4.